universe itself was created in an enormous explosion some 13.7 billion years ago. Before that explosion, there was no time, no space, no energy, and no matter. Right there in that first instant, time began. And space? Well, there was so much pure energy all of a sudden that space itself couldn't stand it. So from just about nothing, space zoomed faster than thought to an enormous size. Good thing too, because gravity was about to squeeze that baby universe back into the nothingness it came from. That first zoom happened a whole lot faster than the speed of light and is called inflation. Since then, the universe has expanded at more of a pedestrian speed of light. At the incredible temperatures and energies of that first instant, nothing, not even matter, was stable. And as quick as it could form, it turned back into pure energy. But as the universe expanded, it cooled. And gradually the basic pieces of normal matter were formed from that incredible energy. Quarks were the first particles to form. Today, quarks only exist in tightly bound groups. But back then, space was so small and quarks were squeezed so close together that they were not bound to other specific quarks. The colors of these quarks just represent a property that attracts them to one another. There are two kinds of quarks in normal matter. Physicists call them flavors of quarks. There's the up quark and the down quark. As space got bigger, quarks lost their freedom and found themselves locked into groups of three inside a proton or a neutron. A proton is formed from two up quarks and one down quark, while its slightly heavier cousin, the neutron, is composed of two down quarks and one up quark. Just about every proton and every neutron in existence today was formed at the time of inflation and was crammed into that primordial basketball. At this point, every neutron was in a desperate race for its life. Since neutrons can only exist for about 20 minutes on their own, every neutron either decayed or got together with a proton to form a kind of hydrogen. Or two neutrons got together with two protons to form the nucleus of helium. All of this happened within the very first minute of existence of the baby universe. Electrons were the final basic particles to freeze out of the energy soup. But the energy density was still way too high for electrons to join together with other particles. And the early universe remained a glowing, cloudy plasma. This condition lasted about 300,000 years while the universe grew and cooled. Finally, it was cool enough for the electrons to be captured by hydrogen and helium nuclei, and the first atoms were formed. Suddenly, light could race through the universe without bumping into charged particles, and the universe became transparent and dark, filled mostly with clouds of hydrogen and helium gas. The light released at that time is still visible today as cosmic microwave background. So how did an almost perfectly dark and smooth universe become littered with stars? Inflation itself caused the first tiny ripples in the density of matter. And over a period of about 10 million years, matter increasingly gathered at these denser locations. After 100 million years, the center of each cloud evolved into a star as massive as 100 suns. Across the universe, these first-generation stars lit their furnaces as their cores became hot and dense enough for nuclear fusion. The universe emerged from the Dark Ages. Because of their huge sizes, these first stars burned with a frenzy, and converted their supplies of hydrogen and helium fuel into the first heavy elements. Essentially, all the atoms in the universe heavier than helium were born in the hearts of stars. In a short 3 million years, the fuel was spent, and these first stars collapsed and exploded into supernovas, spewing their newborn heavy elements out into the universe. This new composition of heavier elements made it a lot easier for gravity to squeeze these clouds of matter into new generations of stars. It took another 500 million years for gravity to do its work on these new mixtures of hydrogen, helium, and heavier elements. Thousands and millions of second-generation stars were born from these clouds. Small groups of these new stars were drawn to each other gravitationally and merged to form ever larger and larger groups. Our own galaxy, the Milky Way, is an example of a spiral galaxy born in this early era. Today it contains about 200 billion stars, and it is still growing as it absorbs small neighboring clusters of stars. The center of our galaxy is a raging dynamo of tremendous power, and it's natural to wonder what could provide such awesome energies.
Black holes.
When a large star is nearing the end of its life, it can collapse under the pressure of its own gravity and become a black hole. These weird bodies are called black holes because they swallow everything that comes close enough, even light itself. The process, though, is anything but dark and serene. This is a photo taken by the Chandra telescope showing stars near the center of our galaxy radiating fiercely as they speed towards their death under the pull of black holes. They are traveling at millions of miles per hour and are being torn apart in the process. There are millions of black holes in our galaxy, and the biggest of them all is the one at the center. This monster has the mass of 3 million suns. Its appetite is ferocious, and it swallows everything in its neighborhood, even other black holes. Probably every large galaxy in the universe has a monster black hole at its center. Until recently, we thought that galaxies were the largest structures in the universe, and that they were pretty evenly distributed. But now we recognize that galaxies join together to form clusters, superclusters, walls, and filament shapes. The Milky Way is a member of a group of 20 or 30 galaxies and star clusters called our local group. The largest galaxy in this group is our sister spiral galaxy, Andromeda. Larger groups called superclusters may contain thousands of galaxies. The nearest of these is the Virgo supercluster, towards which we are being inexorably drawn. Can you feel the tug? This is a map of all the clusters and superclusters within 1 billion light years of Earth. Represented here are some 200 million galaxies, and this is still less than 1,000th of the known universe. From small beginnings, the universe has prospered. 4.6 billion years ago, our solar system started to form about 2/3 of the way out on one of the spiral arms of the Milky Way. Our sun and its planets condensed under the pressure of gravity until the sun was hot and dense enough to light its own nuclear fires. The inner planets are small and rocky with heavy elements, while the outer planets tend to be large gas giants. Our sun is an average-sized star, but it dwarfs the planets. Earth is the tiny planet third from the left. While it would take light itself over 6 hours to travel from the sun to Pluto, let's take a quick tour of our solar system. The planet Mercury is the closest to the sun. followed next by our sister planet, Venus. Our own Earth is third. Our neighbor, Mars. Jupiter is the first and largest of the gas giants, followed by Saturn with its glorious rings. Uranus rolls on its side. Neptune is a blue world. Followed last by X-planet Pluto. And even traveling at the speed of light, it would take us more than 4 years to get to the nearest star. This is Earth 4 billion years ago. There was no oxygen in the air. Molten lava flowed into an already poisonous sea. Hard to imagine, but this harsh environment was perfect for nurturing a miracle. Rain washed the necessary chemicals from the air, and lightning and ultraviolet radiation cooked these chemicals into an organic soup. And somehow, when the smoke cleared, there was something new, something amazing. A very, very special molecule with a graceful spiral shape. And it had talent. It could make copies of itself faster than it could be destroyed. This was the origin of life on Earth. And when this molecule learned to protect itself inside cell walls, life began to transform the planet. 3.5 billion years ago, cells learned how to directly use the sun's energy in the process of photosynthesis, and life grew exponentially. The oceans teem with cyanobacteria, and layers of these microorganisms mixed with sediments became the world's first living structures, stromatolites. For more than 1 billion years, these 3-foot-high mounds marked the limits of life's progress. But more important than the mounds themselves was their waste, oxygen. These new gases, at first toxic to all life, gave rise to the ozone layer. Shielded for the first time from the sun's damaging ultraviolet rays, life became unstoppable. One and a half billion years ago, the cell developed an additional membrane to protect its genes, a nucleus. Now, life was so abundant that every drop of water teemed with organisms. 800 million years ago, the first multicellular organisms began to appear. For a while, multicellular animals just meant collections of identical cells. But gradually these colonies began to have cells that were specialized for different purposes. The first multicellular animals that had specialized cells were sponges. Some of the cells pumped water, and some filtered out tiny bits of food. Anemones and their relatives had muscle cells and nerve cells. This enabled them to bend, stretch, and flex. But none of their great cell diversity enabled them to move. Staying put was a common trait back then. "600 million years ago, an ancient worm was the first animal to develop a centralized nervous system. It had nerve cells that ran the length of its body, and a concentration of these cells at one end formed the first primitive brain. In fact, this was the first animal with a head, and light-sensitive cells in that head were the world's first eyes. It could recognize both the direction and intensity of light. Since it could both see and move, this worm interacted with the world in a very different way. For 100 million years, sponges, anemones, and flatworms dominated the ocean. Then, all of a sudden, if you can call 30 million years sudden, a huge variety of creatures appeared. This event is called the Cambrian explosion. Here is a stunningly developed marine worm. In the course of the Cambrian explosion, competition for food caused both predator and prey to become extremely sophisticated. This is the top predator of that period, a terrifically capable hunter. The Cambrian was a very dangerous time. Only slightly lower on the food chain, another deadly predator prowled the ocean depths. This one had 5 eyes on top of its head and a single extendable claw it used for hunting. Every animal group alive today had its origin in the Cambrian. The first fish appeared more than 500 million years ago, a predecessor to mankind's own group, the chordates. Fish quickly became a success story, getting faster and sleeker and far more numerous. They developed bony spines and, crucially, jaws with teeth. "400 million years ago, much of the earth was already covered in green. Plants had colonized fresh waters and spread onto land. Once they were established, animals soon followed. Centipedes were among the first land creatures. They developed simple lungs and skin that retained vital water. Scorpions, cousins of the horseshoe crab, also made an early move onto land. Their line of 8-legged predators has spread far and wide since then. While the invertebrates were the first animals ashore, others were not far behind. Fish penetrated weed-choked lagoons. Using limb-like fins, they pushed their way through the tangle to stalk their prey. Fins became more and more like legs. The vertebrates were on the verge of a breakthrough. The first amphibians emerged from a swamp some 370 million years ago. Their soft, moist skins absorbed oxygen, and simple lungs allowed them to breathe air. The exertion of hauling themselves over land required plenty of fuel. But the land was now crawling with life. The first flightless insects made easy prey. Many amphibians came to live on land because food was so plentiful. But they were forever confined to the damp places because of their delicate skins. Reptiles evolved from amphibians, but with tougher waterproof skins, they were able to occupy entirely new habitats. Reptiles also pioneered another breakthrough: waterproof eggs. Now they could breed in dry places. Inside the eggs, developing young were housed in a miniature ocean. Reptiles were on the verge of global domination, but one thing held them back. With their skin now waterproof and airtight, breathing became a problem. Lizards breathe by expanding their chest, but because how they walk, they often have to hold their breath. Their waddling gait, inherited from ancestral fish, forces the chest to flex as they walk. Their lungs can't expand to draw in air, and lizards easily become breathless. Ancient relatives of the crocodile, though, found a solution. By standing up on their legs, these reptiles began to walk tall and breathe easier. "270 million years ago, it is hot, and these ancient reptiles need plenty of water. Spending time at the river makes the herds nervous. They know this is a great place for an ambush. Fortunately, this top predator is not hunting. She has recently eaten and also has come to the river to drink. She is 18 feet long and has an armored back. She needs a huge amount of food and therefore needs to defend a very large territory. The only creature on the planet she fears is another one of her kind. $220 million years ago, there's only one giant continent called Pangaea. It is a harsh place mostly covered by deserts. This line of ancient reptiles has met all challenges for more than 100 million years. But now there's something new. A family of reptiles destined to shape the course of life on Earth for the next 160 million years. These are the first dinosaurs. This small raptor has survived the drought along with others of her kind. But they have now been joined by another type of dinosaur. A herd of platysauruses has been drawn to the river. It is hard to believe that these four-legged giants are related to their small cousins. But they are a plant-eating dinosaur. Their size is the key to their success. At 4 tons, they are just too big to be threatened. This is the shape of things to come, and their descendants will only get larger. Further down the river is one of the period's most interesting animals. This is a connecting link between the reptiles and the mammals. As he runs, his backbone moves from side to side like a reptile's. But he has hair and lives in a burrow like a mammal. Deep inside, his mate sleeps on a bed of lichen. The bond between them is strong, and they pair for life. Like all land reptiles, they lay eggs, but after hatching, their young are very dependent and spend most of their months feeding from special milk glands on their mother's stomach. The Jurassic is a time of colossal seagoing monsters. Full of creatures bristling with spikes and clubs, horns and frills, and mountains of flesh so huge they shook the ground beneath them. 125 million years ago, slow movement of the continents is breaking up the northern and southern landmasses, raising sea levels, and opening up new seaways and coastlines. Where once there was solid land, now there are rigid cliffs filled with flying reptiles called pterosaurs. Pterosaurs have been around for 100 million years, and some species are now huge. Wingspans of 20 feet are common, but there is a species that dwarfs them all. This giant is 40 feet from wingtip to wingtip, with a body bigger than a man's. He is the undisputed king of the skies. This little mammal is a scavenger. She is a marsupial and specializes in raiding abandoned dinosaur nests. This evening, she thinks she is in luck. Unfortunately, the smell of food has blinded her to the danger. "65 million years ago, a meteor just 10 miles wide abruptly ended the reign of the dinosaurs. "3,000 miles to the north, the effects are about to arrive. The light from the impact fades in silence. The shockwave arrives. Next comes the blast front. Molten rocks starts to fall out of the darkening sky. The meteor hit the Gulf of Mexico with a force of 10 billion Hiroshima bombs. With the catastrophic climate changes that followed, 65% of all life died out. It took Earth millions of years to recover, and when it did, the dinosaurs were gone forever. It is a time called the Eocene, and Earth has healed itself from the ravages of the massive meteor strike. A lot has changed since the time of the dinosaurs. It is hotter now, and tropical rainforests have sprung up on every continent. The top predator now are the dinosaurs' direct descendants, the birds. There are many varieties in this weird habitat, and the largest is 1,000 pounds of muscle and feathers, and is as tall as a grown man. From small beginnings, mammals are now prepared to take over the world. Over the course of 40 million years, mammals have become more and more successful until they are the biggest, fiercest, and most spectacular animals on the planet. Whatever the climate and whatever the habitat, mammals made it their own. Their great strength was the ability to adapt. They grew in huge sizes. They evolve into powerful killers, and they laid their claim on the oceans. And then, around 6 or 7 million years ago, we have our first ancestor that is not also an ancestor of any other living creature. This is Tumai. It is the oldest known hominin and dates between 6 and 7 million years ago. Auroran dates about 6 million years ago and was probably bipedal. Ardipithecus lived from 5.8 to 4.4 million years ago. This is Kenyaanthropus from 3.5 million years ago. This is Lucy, an Australopithecus afarensis from 3.2 million years ago. Meet Australopithecus africanus. He is from 2.5 million years ago. Homo habilis, from 1.9 million years ago, was found with tools. Homo ergaster dates to 1.6 million years ago. Homo erectus lived from 1.8 million years ago until 300,000 years ago. This specimen is from 500,000 years ago. This woman is the mother of all mankind, the common ancestor from whom we all descend. She lived 150,000 years ago in East Africa, and everyone on Earth is related to her. Over the next few million years, some of our ancient relatives left Africa, discovered fire, tools, and clothes. The human species evolved and multiplied. But due to climate changes, the only modern humans to survive were those that stayed in Africa. This woman is the mother of all mankind, the common ancestor from whom we all descend. She lived 150,000 years ago in East Africa, and everyone on Earth is related to her. 80,000 years ago, severe climate conditions have again reduced the number of modern humans to fewer than 10,000. They are scattered throughout Africa in small groups. In an effort to find food, one group living on the east coast attempted a crossing of the Red Sea to the far coast of Yemen, a distance of only 10 miles, but a difficult and dangerous journey. They were successful, and every non-African in the world today is descended from this group. While some of our ancestors stayed in Yemen, others moved east along the coast of the Indian Ocean looking for warm, gentle places to stop. It took 6,000 years after reaching Yemen, but our ancestors ate their way to Malaysia. 6,000 miles from Africa, they were deep in the tropical rainforest of Southeast Asia, living a life of hunting and gathering. They roamed in small bands. They stayed in one place only long enough to reap the harvest of the wildlife, and then they moved on. Their bodies gradually adapted to the rainforest conditions. Away from the harsh African sun, their skins became lighter, and their stature was reduced by a lack of meat. The Toba eruption happened in Sumatra 74,000 years ago. It was the single biggest explosion on Earth in the last 2 million years. The plume was 25 miles high, and it plunged much of the world into 6 years of ash-covered darkness. Once again, our ancestors had to move to survive. 74,000 years ago, sea levels were 160 feet lower than today, and most of the islands of Southeast Asia were joined together in a single land mass. Running to escape from the Toba eruption, humans were pressured to cross to the unknown continent of Australia. 100 miles of shark-infested seas was an intimidating barrier. But amazingly, the evidence suggests that wave after wave of our ancestors made this perilous journey. For 30,000 years, harsh deserts blocked the passage from Yemen into Europe. But a favorable climate shift finally brought the rain. Rivers swelled and the game spread north, and our ancestors followed the game. They spread quickly into the Mediterranean, then south along the coast into North Africa, and up through the Balkans, and into Europe. "50,000 years ago, our ancestors entered what is now Germany. But they were in for a surprise. Germany was not empty. Another line of hominids that had left Africa over 250,000 years earlier was now the master of Europe. And although they had brains fully as large as modern humans, Neanderthal did not survive this contact. They were soon extinct. By 35,000 years ago, our ancestors were creating art and other treasured objects. Carvings from this time can be delicate and expertly done. Cave paintings, as well as carvings, were sometimes symbolic and sometimes representative of actual people or animals. Paintings often depicted the prey they were hunting. In some cases, dangerous animals such as lions or woolly rhinoceros. Other paintings may have represented magical or imaginary creatures. By 25,000 years ago, our ancestors had trekked north from Southeast Asia and east from the steppes in Siberia. The migration converged at the Bering Strait, connecting Asia with North America. Until recently, archaeologists believed that humans reached North America about 15,000 years ago. But new evidence places our ancestors crossing the narrow land bridge into North America between 20 and 25,000 years ago. Advancing ice from the north smothered the central plains and forced the migration down the west coast into South America. As the ice retreated, they spread back northward. There's evidence of a settlement in a rocky shelter on the Ohio River in Pennsylvania that was inhabited more than 16,000 years ago. By 8,000 years ago, humans had mastered herding, and other skills. Agriculture, metallurgy. Civilizations sprang up around the world and included Babylon, Persia, Egypt, Greece, America, India, Samaria, and China. From those civilizations to our own is a matter of history. "1,000 years ago, Chinese astronomers observed the first supernova in modern history. Today, we see its remnants as the Crab Nebula. 130 years ago, Dmitri Mendeleev arranged the elements that are created in the hearts of stars into today's periodic table. About 100 years ago, Thomson discovered the electron, Rutherford discovered the nucleus, and Bohr put together the first detailed description of an atom. About 80 years ago, physicists concluded protons existed inside the nucleus. And about 70 years ago, Chadwick discovered the neutron. About 30 years ago, Murray Gell-Mann theorized the existence of quarks. Existence of the final quark cousin, predicted by his theory, was confirmed in 1995. Penzias and Wilson discovered the cosmic microwave background, and 10 years ago, an experiment detected ripples in the thermal nature of that background, thus confirming inflation. The universe was created in an enormous explosion some 13.7 billion years ago. Before that explosion, there was no time, no space, no energy, and no matter.